You're in that right triangle. Okay, a squared plus b squared equals c squared. Now just remember, a is a leg, right? B is a leg, c is the hypotenuse. So we've got here is going to be leg is x, another leg is 7, and the hypotenuse is 13. So we're looking at x squared plus 49 is equal to 169. X squared then is equal to 120, and then x is root 120, okay? If you had root 120, you got answers, or you got credit, okay? If you change that to x equals 10.95, you got credit. If you change that to x equals, you wouldn't round this way, this would be an incorrect rounding, but if you read 10.9, I give you credit. If you read round to 11, I give you credit, okay? I was hoping that we would get to that, and then recognize that actually, what number divides 120 that's a perfect square? Or what number divides 12 that's a perfect square? 4. So if 4 divides 12, it's also going to divide 120. And what's nice about it is that it is the largest perfect square that actually divides 120. So I was looking for 2 radical 30, okay? And my hope is that we eventually, just for your sake as a math student next year, following year, okay, as far as you go with math, that you always seek the best exact answer, because then once you have that, if you ever need to round, you have the ability to just type that in your calculator and round to whatever decimal you need to, right? But if I go and I find it as 10.95, and I don't have any work showing that 10.95 or anything like that, when I go back to it later, I can't find the exact answer from 10.95. But I can always find the rounded answer from 2 radical 30. Okay, so that's kind of the mindset I hope to, over the next, how many more weeks we got? About 15 weeks, 14 weeks? Been counting? Can't count?
I'm going to say 12.
I think you're right. We got 3 more weeks. 20th is the end of 9 weeks. And then we got 9 more. So yeah, good job. Smile once in a while, Hunter. All right, so 2 radical 30. That's what I was looking for. The next one, okay? This was my hope. Now I know, and this is, I'm not, I don't know the best way to phrase this. When we're learning something initially, and that's the current topic that we're talking about, it's hard not to use that, right? So when I gave this to you, we were currently working on SOHCAHTOA, right? Sine, cosine, tangent. And a lot of people used it. And that's fine, because my directions don't say whether you can or can't, right? But my hope was that we recognize that this is a 30, 60, 90 triangle, right? In a 30, 60, 90 triangle, isn't across from the 30 in, across from the 92 in, and across from the 60 in radical 3, right? Does that number there match to that? 16 equal 2 in. So what's n going to be? 16 equals 2 in. N has to be 8, and that matches to the x, right? And then the y turns into 8 root 3. Okay? That was my hope that you went that approach. Okay? Now, absolutely nothing wrong, because of my directions, to do this. So a lot of people say, well, this x side is the opposite side. The hypotenuse is 16, and y is adjacent. So in finding x, they use sine of 30, because that's the angle provided, right? We're going to find x, because that's the opposite, and we're going to use the hypotenuse. So say x over 16, multiply both sides by 16, and we get x. Okay? So then they grab their calculator, and internet's slow today. Make sure you're in the right mode. Go degrees. And we're going to type in 16 sine of 30. And what's the spit back? Gives me the 8 that we knew we should have gotten if we would have used special right triangles, correct? And that's the thing about this stuff. If we can get an answer one way and then get an answer a second way, those two answers better be the same, right? Okay. Or if they're not, one of those routes was inaccurate. Now the next one, if I want to find y here, y is the adjacent side, 16 is the hypotenuse. So which trig ratio uses adjacent and hypotenuse? What uses A and H? Cosine. So I'm going to go cosine of 30 degrees is equal to adjacent over hypotenuse. So now it's going to go 16 cosine of 30 gives me y. Okay? So 16 cosine 30 gives me that y value there. And I accepted 13.85. Okay? But that's not the exact answer, because that last 6 there, I'm not sure if that should be a 6 or if it should be a 5. That's one thing. That's one issue. And I'm not certain, let alone whether that is a 5 or a 6. There's an infinite number of values after that, okay? For this reason right here. If I look at a 30, 60, 90 right triangle, because that's what we're dealing with, and we just go ahead and write this as n. This says 2n, and this says n radical 3, right? Okay. Don't even care what these dimensions are, 16, 8, whatever, doesn't matter. When I ask for the cosine of 30 in this picture, it is n radical 3 divided by 2n, right? What's going to happen with those n's? Cancel out, right? So it's no longer algebraic, it's radical 3 over 2. So if I type in cosine of 30 on this, cosine of 30, I get that decimal, right? That's the same thing as the square root of 3 divided by 2. That's what that process on the left was showing us. What that means to me, so if cosine of 30 is actually radical 3 over 2, then when I did that multiplication right there, I multiplied 16 by an irrational number, radical 3, right? And a rational number times an irrational is going to be irrational. Does that make sense? Meaning this product here goes on forever, never ends, never repeats. So if I do chunk that off, if I do chop it right here, it's really not 16 cosine 30 anymore. Does that make sense? Okay. Or if I, cut it off there, it's better, but it's still not the exact size that it should be for 16 cosine 30. Okay. So we've got rounding issues there. But if I use the 30, 60, 90 approach, the 30, 60, 90 approach says that this thing is, 8 radical 3. Okay, and that is a better answer than either of these decimals. Okay, so that's just something to think about. I told the last class, if I'm going, a lot of times that I've actually used this math outside of teaching it is like renovating my home. Okay, updating my basement, that kind of stuff. Because I want to make a plan before I go buy materials, right? Because if I make a plan before I go buy materials, I'm going to save myself a lot of money, a lot of heartache, that kind of stuff, okay? So I make these plans and I make geometric representations of things and determine distances and that kind of stuff. So I use this stuff. When I go to Lowe's, and I tell them, hey, I need 16 cosine 30 feet of lumber. Or I say, hey, I need 8 radical 3 feet of lumber. The person working at Lowe's is probably going to tell me to go to Menards. Okay, because they don't want to deal with me. Does that make sense? Because it's not, those aren't numbers you go to Lowe's with, right? I'm going to change that. I need, 18 or 13 number? I'm going to say, hey, I need 14 feet of lumber, right? I'm going to round that. But let's think about this. Let's talk about another application. If I'm working for the United States government and my job is for maybe software and programming for GPS, okay, and those satellites. Do I want to take a 13.8 number that I've gone through in my math and the triangulation of GPS, because GPS uses a lot of these triangles and a lot of the angles that we're talking about. Do I want to go through and use a bunch of rounded values? No, because Hunter then is impacted by that, because Hunter's got his phone, which is connecting to the government's GPS, and it tells him where he's at, right? It tells him where he needs to go. So let's say Hunter, not using his phone, but let's say you're an avid skier. You like to ski? You ever been skiing before?
What type of skiing?
Snow skiing.
Yeah.
No? What type of skiing have you done?
The one where you ride on the boat.
Okay. On land? Water ski. Okay. So let's say he's a snow skier, and he gets in an avalanche. Okay, and he's got GPS on him, but he gets in an avalanche. You ever watch him search for somebody in an avalanche? They take these big poles, and they just basically start jabbing down on the ground until they hit somebody. Because you can't see them, right? They're covered in snow. And it could be, 5 to, 15 feet of snow. So they can't hear him yelling. If he's got GPS, that's good because it's going to take me straight to him, right? And I can search. Okay, now when he's under the snow, he doesn't have a whole lot of oxygen, right? So time is limited, correct? So I want GPS that's going to take me straight to him, okay? But if let's say he's got GPS that they rounded some numbers with, and he's under my desk, that's the snow, he's under my desk, and I'm right here, and I'm jabbing for him, and I can't find him, right? And let's say I jab for him for 30 minutes. What has he done in that 30 minutes? He's died. Okay? I'll find him, but I'm not going to find him alive, right? Okay? So wouldn't he want the GPS to be using valid numbers, not rounded? Okay? You guys ever, last class we were talking about this, you lose your phone, you get on, like, if you got an iPhone, or I don't even know if Android has this, but like Find My Phone.
Yeah.
Like I lose my phone, my wife, we probably lose our phones probably like 5 times a day. And like our kids, our 5-year-old will take them and she just wanders off with them, like watching YouTube and Frozen and that kind of stuff. And then she'll tell us where she put it, and it is nowhere close to where she told us she put it. So we'll get on our laptop or wherever and search to see where it's at. Sometimes it works, sometimes it doesn't. But sometimes it'll tell me, hey, your phone, it'll show our house or whatever, and it'll show the phone like in our bedroom. When I actually find my phone, it's like in my car. It makes no sense that where it showed the relationship to the phone, because that GPS, for whatever reason, is not very accurate. And that's what would happen if they're using rounded values. I'm not saying that they are in that case, but that's not always really all that accurate, right? Okay. Now and it's because the GPS, the software there is free, right? If you're a skier, you're gonna go buy like a legit GPS instrument, right? And it's gonna probably cost you maybe hundreds or thousands of dollars, because that's what your life is worth, right? Your life's only worth $100? No. You're going to spend more money on that, because in the case that you're in an emergency, you want somebody to find you. But that's the idea. If I'm working for NASA, I'm working for the government, with those types of things, rounded values should not be used. I don't know if I've told you this before. A couple years ago, Great Britain, they've got like their own NASA. I don't know what it's called. But they were doing a program that was $14 billion. It was 2 stages. They were going to send a probe to Mars, $7 billion. And then like 10 years later, so they send the probe to Mars, and then they work on a new probe, the second part of this project, for another 10 years, and that was another $7 billion, which they had already allocated workers to, and they're already working on. So the first one that they sent to Mars was supposed to like deploy a parachute and drift down to the surface of Mars. The math that was used delayed that parachute by fractions of a second. And when it released, it didn't give the probe enough time for the air to fill that parachute, so the probe smashed into the surface of Mars, wasting $14 billion. Okay? Just because one calculation was off by a fraction of a second. Okay? So, I didn't do any more like reading about it or anything like that. It could have been somebody just did a rounding error somewhere. Does that make sense? So those are things that is it going to be $7 billion, $14 billion to go to Lowe's and have rounded values for buying lumber for a deck or something like that? No. But there are things that we hopefully understand and realize specific values or exact values are necessary. This next one, 45, 45, 90, right? Okay. You could use SOHCAHTOA here because I didn't tell you. But isn't this my in radical 2 side? Isn't this 3 radical 2 and a 45, 45, 90? Isn't that in radical 2? So what's in match up to here? In matches up to 3, right? So can I write this as 3 there and 3 there? And now working on the triangle to the right, isn't this my n radical 3 side? So then I'm going to come to the side, I'm going to say 3 equals n radical 3. I'm going to divide both sides by radical 3, and that's my n side. What do I need to do with this n side to get my hypotenuse? Remember in a 30, 60, 90, if that's 60, this is the n radical 3, this is the n, and this is the 2n, right? So if n is this, we need to double it to get the hypotenuse. So I double that and I get 6 over radical 3. Then you can leave it that way, because I didn't tell you to simplify. But if you did simplify, you would have found that you get 6 radical 3 over 3, and that's going to cancel and give you 2 radical 3. Okay. If you used SOHCAHTOA, I'm just going to put 2 radical 3 in here as a decimal. You got something in the ballpark of 3.46. SOHCAHTOA, here you would use sine of 45 is equal to opposite over 3 radical 2. And that will give you still that 3 right there. And then down here you would use sine again, sine of 60 equals 3 over x. Okay, so if I go sine of 60 equals 3 over x. To solve that for x, the sine of 60 and x actually switch spots. So I'm going to type in sine of 60 here. And then this would be x. Does that number there end up being the same thing as the 2 radical 3? Okay. So you could use that SOHCAHTOA there. This one here. What do I have to use there? There I have to use sine. I have to use sine of 50 is equal to 10 over x. Opposite, this is the opposite side. That's the hypotenuse. And because it's a 40, 50, 90 triangle, we don't have a template for that. There's nothing special, so we have to use sine, cosine, and tangent. Now if I go through the algebra here, it's going to give me x to be 10 divided by sine of 50. Okay? Type that into your calculator, and you're going to get 13.05 back. And I didn't tell you how to round, so if you put 13 in, you put 13.1 in. Anything in that area I gave credit for. Okay? Now that's a rounded value, right? It's not very good. Okay? You guys, and we talked about this a little bit yesterday, I think. You guys did like percent error and percent change and that kind of stuff in labs and science, right? Well, if I want to mitigate any percent error in my science stuff, I want to make sure that I don't have rounded values, right? Or maybe I pay special attention to like sig figs and all that kind of stuff. Thinking about using this number in another calculation. Let's say I have to use 13.05 somewhere else. It would make more sense to use that number, okay? So because if I'm simply just going to double this, if I just double 13.05, everything after that 5 that I cut off is not getting doubled. Therefore, I'm underestimating what the actual value is. But if I take this and double it, it's just going to take that 10 and make it a 20. Okay? And with those values, that 10 or that 20 and that 50, were any of those numbers rounded? Looking at my triangle, when I took the 10 off, did I round that? When I took the 50 off the triangle, did I round that? So nothing was rounded in that calculation. So 10 over sine of 50 is the best answer. That's kind of like leaving it as a radical. Does that make sense? Okay, because sine of 50 is an irrational number. Okay, so that's the simplified exact value if you were to ever ask for an exact value. Anybody take the ACT lately? Anybody ever take the ACT? When you get to the ACT, there's going to be questions on it towards the end that have trig in it. Your options, like A, B, C, D, probably on some of those questions won't be 13.05, but they will be that right there. It's just a different version of 13.05. It's in the exact version. Is that okay? Last class, I briefly talked about a question out of 8.4. Just to, some people have voiced to me that they're concerned about these angle of elevation questions and drawing the pictures and interpreting the pictures. Okay, so I just want to kind of ease some anxiety with that for a moment. On your tests and quizzes and stuff like that, I will give you most of the pictures that you need, okay? And this is the reason why. When you read something, okay, you might interpret it differently than your neighbor reads it, right? Okay, the way I've worded this question up here, I've intentionally worded it so that you or your neighbor might think of it differently, okay? Now, you should still, no matter how you approach it, you still get the same answer, but your procedure based or off of your neighbor's procedure could be different, okay? So I just want to kind of discuss this and talk about it. And that's the reason why I'm going to draw the pictures for you or give them to you on tests and quizzes. And the end of course exam traditionally does the same, okay? If there's a angle of elevation question, they usually help you out a little bit with a picture, okay? It says to measure the width of a crater on Mars. The Mars probe travels at an altitude of 5.3 kilometers above the Mars surface. The onboard guidance system measured the angles of depression to the far and near edges of the crater and found them to be 14 and 23 respectively. Find the distance across the crater. One thing we need to talk about here is the word respectively. If I were to say Mr. Fay and Hunter are 35 and 16 years old respectively, who is 35, who is 16? Based off of the phrasing, not anything that you know about us. Mr. Fay and Hunter are 35 and 16 respectively. Hunter's the 16, I'm the 35, right? Because I said my name first, and then I said 35 first when I was using the numbers. Does that make sense? I said Hunter's name second and 16 second when using the ages again, okay? So here, there are two things that are happening here. They're giving me phrasing of far and near, okay? And then they're giving me values for angles of 14 and 23. Well, far comes first, right? Or 14 comes first. So far and 14 go together. Near and 23 go together. Does that make sense? Okay, that's what that word respectively means. In this problem, it's not gonna create any issues for you if you mess that up. But sometimes per story problems on the ACT or the end of course exam, that word respectively could throw a wrench into everything. Okay, so I think it's important to know that. Another way of maybe kind of eliminating the need for respectively, think about being close to something. If I'm right now, like if I'm standing over here and I want to look at my clock, okay, let's think about angles of elevation here. And the same thing happens with angles of depression. If I'm standing here looking at my clock, right there would be a horizontal, right? Okay. This would line my eyes up with the clock. So that would be my angle of elevation, right? Okay. Pretty small angle, right? If I'm looking at my clock from here, there's my horizontal again. Now I look at my clock, I have to tilt my head up, right? How does that angle compare to the angle that I had back there by the windows?
It's bigger.
It's bigger, right? Okay. The closer I am to something, the more severe the angle of elevation has to be to see it, right? So the closer you are to something, the larger the angle of elevation or depression, okay? So that kind of makes sense here when I say far is 14 degrees, because that's shorter or smaller, and near is 23 degrees, that's bigger, okay? So draw a quick picture here. I don't want to do, or we're not going to do all of the math here, but I want to kind of make a comparison of how people may interpret these. So let's say this is the near edge, and let's say this is the far edge, and I'm trying to find the distance across. Let's say my probe is right there. So the line of sight to the near edge would be there, and the line of sight to the far edge would be there. Is that okay with everybody? You have a line of sight, and line of sights along with a horizontal are going to provide your angles of depression. So the near is going to be 23 degrees and the far is going to be 14 degrees. Does that make sense to everybody? So those are the two angles. Okay, now think about that horizontal and that horizontal. They should be parallel, right? Can I take that 23 and put it right there? Can I take that 14 and put it right there? Okay. Now the purpose of doing that is because this probe is 5.3 kilometers off the ground. If I look at that right triangle, can you find that distance right there? I'm just going to call it lowercase a. If I look at that right triangle, and just maybe from some of the homework questions I give you in Math Excel, if that's 23, that's a, that's 5.3, why don't you say that the tangent of 23 is equal to 5.3 over a? Does that make sense to everybody? Okay. Now, look at this one. Using the same logic, could I find that distance B? So that triangle is going to look something like this, where this is 5.3 and this is B. There's 14. Could I say tangent of 14 is equal to 5.3 over B? Those two equations are finding A and B, right? What would I have to do with A and B to find the distance across this crater? Say, okay, so you're gonna find these. So you're gonna take 5.3 divided by 20, tangent 23, right? You're gonna take 5.3 divided by tangent 14, and that's gonna give you A's length. That's gonna give you B's length. But then what would you do with those two lengths to find the distance across the crater? Add them together, right? Does that make sense to everybody? So that's what we're gonna add those together. I'm gonna come to the side here real quick, and I'm gonna eliminate all the math here. But let's say that my crater is here. There's the near side, there's the far side. I'm gonna find that. But let's say my probe is there. Now my right triangles are a little bit different. Those are my right triangles. If you watch the video that I asked you guys to watch the other day, this is kind of the picture of Oscar on the lighthouse. Okay, so I give you that triangle where this is 5.3. That is actually going to be, so if we looked at our angles of depression, to the far one would have been 14, to the near one would be 23. Through alternate interior angles, this ends up being 23, and this ends up being 14. Can you find, if that's a right triangle, can you find that distance right there? I'm gonna call that A for now, okay? Then I'm going to look at this green triangle. Because you got 5.3 of that green triangle, you've got this 14. Could you use that stuff to find that distance, B? That makes sense? What would you do with those two values to find the distance across the crater? What would you do with B and A to find the distance across the crater there? You're going to subtract them now. Does that make sense, everybody? Okay. So the way that you interpret, because the question there says that the probe is directly above the crater, to the east of the crater, to the west of the crater, anything like that. Now, if I added those words, that would eliminate the confusion, but the way you interpret it might be different than the way somebody else interprets it. So your process would be a little bit different. Now, if you did this either way, if you did both of them right, you're going to get you're going to get the distance between N and F to be the same. And I think it's like 35 something. But the way you interpret these questions is a little bit different. So that's why we'll add the pictures for you. Does that make sense? Okay. I would like to give you another one of these. You can use anything that we've talked about. No new homework tonight. There was a question earlier about whether there was a quiz tomorrow. Still don't know. Still don't know. For you, so these things, guys, again, I want you, hopefully this creates like a need for us to take more notes instead of just watching. Or I was telling the last class, I asked, does anybody, Hunter, you play baseball, right? You're gonna go practice tonight, right?
Yeah.
You don't participate in practice?
Yeah.
Okay, that's gonna get you better at practice, right? Drake, you go to track tonight, right?
Yep.
What event do you do in track?
Discus and jump rope.
Discus. Do you get better at discus by watching somebody else do it?
No.
No. So did anybody that just watched me do math today, anybody else get better at it? Probably not, right? If you're just sitting and watching, you're not getting better at things. You have to participate, right? Those of us that took notes today, asked questions, participated, probably did better. You're going to demonstrate that on that half piece of paper. So we want, hopefully, these things get us to do that, okay? Give us opportunities to take notes, use those notes. So on these, use your notes, use your calculators, that kind of stuff. Some of those tell you how to round. Some of them tell you not how to round. So the ones that don't tell you, it's up to you.